Hello everyone. Uh, in this video, I'm going to explain you about ML programming language. ML programming language. ML doesn't stands for machine learning. Okay. So most of the times we feel ML is for machine learning. No, it is ML and it is a meta language which is introduced by Milner in the year of 1997. As every language is belongs to one of the language category, the same way ML is a programming language which is belongs to functional programming language. In the last video I told you very clearly about programming languages either belongs to any one of the category. There are categories we were discussed in the last video: imperative, object oriented, logic programming, functional programming, script oriented. These are what the programming languages. If I am picking one of the programming language, that should be belongs to any one of the category, at least one of the category. Now ML is a programming language which is belongs to functional programming language. Okay, when I'm bringing this point into your mind, now you may have a question: what is the difference and similarities in between the other functional programming languages? Other functional programming languages, what we were discussed is Lisp, Schema, and Common Lisp. So Common Lisp also one of the programming language where it is dialect of this Lisp. Right now, when you look at these three programming languages, all three are belongs to functional programming language. Now I'm saying this, ML is also functional programming languages. Now there are difference. The difference is what? ML is static scoped language. We heard this term in the other language, which is schema. Schema and ML are static scoped programming languages, and there are other things where these will have similarities that we'll see throughout this video. We'll talk many times the similarities and differences when particular point comes. Now, the major similarity in between ML and schema is both are static scoped languages, and however it differs from Lisp and its dialects including schema in a number of significant ways. The other thing which differentiated the Lisp and ML is a strongly typed language, whereas Lisp is typeless language. ML is strongly typed language. Now, when I'm saying it is a static scoped language, how the declarations will be go ahead, or what we will declare. When I'm saying it is a static scoped language, how scope will be applied, on which entity scope will be applied, whether the entities are variables and identifiers and constants. Let's see. ML has type declarations for function parameters and the return types of functions. So ML has type declarations for functional parameters. That means if I wanted to declare a function, let's see, I wanted to declare a function of q. Now I am having some parameter x. So now what this point is teaching us? This point is teaching us that function parameters will have type declaration. That means I am going to declare x into real. What does it mean? X is belongs to real data type. If I do not give data type to the parameters of the function, it will be treated as integer because the default data type is integer. So cube of x function is taking a parameter which is x, and the parameter data type is what? Integer. If I wanted to change the data type, now I am going to give real. So what does it mean? We'll not have, we will be having type declarations for function parameters. That's what it is, strongly typed language. And the one more interesting point, the type of every variable and expression can be statically determined. And there is the other similarity. Like other functional programming languages, it doesn't have variables. What doesn't have variables? ML doesn't have variables in the sense of the imperative languages. Now there are two terminologies what we have to think. Functional programming languages, imperative languages, variables. Look at these three terms. The way how variable will get instantiated into imperative language is different from the variable instantiation in functional programming language. Now, what do you mean by instantiation? Instantiation is bounding a value to the variable. Bounding a value to the variable is called as instantiation. Let's see that if I write x phi, what does it mean? Phi is a bounding value which will bound to the variable. So this is called as instantiation of variable x. And the other interesting point about this ML is it does have identifiers which have the appearance of, it does have identifiers. I told you uh, very particularly that it doesn't support variables. It doesn't support variables, but it does have identifiers which have the appearance of names of variables in imperative languages. However, these identifiers are best thought of as names for values. A table called the evaluation environment stores the names of all implicitly and explicitly declared identifiers. I told you variables are not supported but identifiers. So these identifiers can be declared implicitly or explicitly, and the values will get stored into evaluation environment. This is like a symbol table. This is like a symbol table. Another important Another important difference between schema and ML is that ML uses a syntax that is more closely related to that of an imperative language than that a Lisp. Now let's see the syntax, how a function will get created. So arithmetic expressions are written ML using infix notation. We know it, right? +7 3, it is what infix notation. Now, how function will get declared in ML as we'll use a keyword which is fun, F-U-N, fun. We'll use this keyword to define a function. Function name and formal parameters equal to expression. Function name, formal parameters equal to expression. When we call the function, the value of the expression is returned by the function. The value of this expression will be returned by the function. Actually, the expression can be a list of expressions separated by semicolons and surrounded by parentheses. The written value in this case is that of the last expression. Now look at this thing, you may be understanding what I am talking over here. Because we are not considering the parts of ML that last serve no purpose, because we are not considering the parts of ML that have side effects, we only consider function definitions with a single expression. Now we can discuss what is type inference. Now consider the following ML function, which is some function name and some expression. This specifies a function named circumference that takes a floating point, that is real in ML, parameter and produces a floating point result. The types are inferred from the type of the literal in the expression, likewise in this function. Now look at this function, fun times 10 of x is equal to 10 into x. The parameter and functional value are inferred to be of type integer. Now here the data type is real, and as the value is real, the whole expression will return the value of real. And this is what 10 into x, 10 is an integer. The parameter and functional value are inferred to be of type integer. Okay. Now look at this statement, fun square of x equal to x into x. Now I did not given any value over here. So as far as type inference is concerned, if the value of the expression somehow it is having real, then this value also will produce the real. Somehow if it is having integer, the value inferred to be a type of integer. But in this case, the value is not defined either real or integer. Okay. So leave this line. Now look at the above statement. It is what function, what it is have some expression. So here what happens? It would cause an error when we call this function. Now I am calling the function which is square 2.75. So I told you just before in the last paper, I believe, that so the default data type of ML language is what? Integer, the default. Now in the definition part of function, as I did not specify any data type, these will be integer. While I am calling the function to perform it for a different parameter which is 2.75. Now it is what? Real data type. It would cause an error because ML doesn't coherence real values to integer types. If you really wanted to find out the square of this number, then the real parameters, it could be rewritten as function square of x colon real equal to x into x. In this case, this statement will give you an successful execution because it is a default data type integer, but I wanted to pass this parameter to perform. This parameter belongs to real data type. Hence, in the function definition, my formal parameter will be defined with real. And function square of x is equal to x. These are what the ways of defining the parameter. These are what the ways of defining the parameter. I think you might have understood type inference in the sense how type will get inferred to the variable. So as far as ML is concerned, that will be inferred with the value what is expression is holding. So if it is real, then the expression will return real. If it is integer, it will return real. If no you specified any kind of parameter data type, then it will be treated as integer. But while in the function call, you have to keep in mind how it will get evaluated. Type inference is also used in the functional languages Miranda, Haskell and F-sharp. So that's what we were not seeing the same kind of things in Lisp and common Lisp and schema, whereas you don't have this feature. So the feature what we have explained, ఒకవేళ ఎక్స్ప్రెషన్లో ఫ్లోటింగ్ వాల్యూ ఉంటే ఆ ఎక్స్ప్రెషన్ అంతా మీకు రియల్ ఇస్తుందని, ఒకవేళ ఎక్స్ప్రెషన్లో ఇంటీజర్ ఉంటే ఆ ఎక్స్ప్రెషన్ ఇంటీజర్ అవుతుందని, ఈ ఫినామినా వేరే ఫంక్షనల్ ప్రోగ్రామింగ్ లాంగ్వేజెస్లో లేదు. కేవలం మిరండా, హాస్కెల్, ఎఫ్-షార్ప్ అండ్ ఎంఎల్లో మాత్రమే ఉంది ఈ టైప్ ఇన్ఫియరెన్స్ అనేది. సో టైప్ ఇన్ఫియరెన్స్ అవ్వడానికి మనం ఫంక్షన్ కాలింగ్లో ఏది తీసుకుంటామో దాన్ని బట్టి మనం డేటా టైప్ని చేంజ్ చేస్తాం. అది మనం చూసాం, ఇది ఇంపార్టెంట్. ఓకే, ది ఎంఎల్ సెలక్షన్ కంట్రోల్ ఫ్లో కన్స్ట్రక్ట్ ఈజ్ సిమిలర్ టు ది if the imperative languages, I mean of the imperative languages. That means, so the way how selection control statements were being used in imperative languages, ML also have the if statements, something like if expression, then expression, else expression. You can see this sample code. Fun fact n colon integer. Now question comes from your mind and it has to be also ఇంటీజర్ అని ఎందుకు రాసా నేను? ఇది రాయకపోయినా కానీ ఇది ఇంటీజరే. ఎందుకు? ఇది డిఫాల్ట్ డేటా టైప్ కాబట్టి. ఒకవేళ రాయాలి అనుకుంటే ఇలా రాసుకోవచ్చు అని అర్థం. ఇఫ్ n less than or equal to 1, then 1, else n into fact of n minus 1. So we are not new to this type of coding, but we are very familiar the way how factorial will get implemented through if and else. And there is one more thing where fun fact of 0 equal to 1, fun fact of 1 equal to 1, fun fact of n into n of int equal to n into fact of n minus 1. It is what the ways of writing the code with control statements and without control statements. And in ML, names are bound to values with value declaration statements of the form where I can give that val new name is equal to expression. So we will not specify the data type of this new name, but we will give only to specify it is a name. Name something it is holding. To specify it, we'll give some val. So val distance equal to time into speed or anything you can take. But some identifier, if it is going to have some expression, then we will be taking this val. ML has enumerated types, arrays and tuples. ML also has exception handling and module facility for implementing abstract data types. So this is all about ML, and most of the things you might have understood. If it is not, please go through the same video for second time. I'm sure that you can understand more things about ML. So ML, why it is strongly typed language, why it have type inference, all these things are the key characteristics of ML or functional programming characteristics of languages. So this is all about ML. Thank you all.